9 megapower electrosurgical unit instructional video. In this video, we'll show how to do a power output test using a Fluke QA-ES chip.
I'll let you know when to hit record. Never mind. Make sure the power cord is in good condition and not frayed. Snugly plug the power cord into the machine and the other end into the wall. Make sure the outlet that you plug into is grounded. Power the QA-ES2 and let the firmware boot. Once the firmware is booted, you may begin setting up for the power output test. Install the patient return lead into the ESU. The lead receptacles are located on the right side of the QA-ES2. Install the patient return lead into the common receptacle. Plug the active test lead into the appropriate monopolar receptacle. Then plug the opposite end of the active test lead into the load receptacle. You may now power the ESU. Refer to page 26 of the ESU User's Manual for the appropriate power and resistance settings. Apply the referenced settings. In this case, Pure Cut has been selected with a power setting of 300. Press F2 to scroll through the knob parameters. Rotate the knob to adjust the selected parameter. In this case, the rated load is 300 ohms. Press the Enter key to finalize your selection. Press F3 to start the test. Activate the connected ESU function and observe the test results. Also note that the RF detect LED lights when the test is active. To perform bipolar testing, you should first remove the patient return electrode from the QA-ES2. Insert the common lead into the bipolar receptacle. Remove the active lead from the monopolar receptacle and insert into the bipolar receptacle. Insert the common lead into the common receptacle of the QA-ES2. Again, refer to page 26 of the ESU's Operator's Manual for test settings. Input power and resistance settings and begin the test. Press the bipolar foot switch and observe the test results.
The IDA5 is really accurate and fast. We use Hospira infusion pumps. Before we used the IDA5, we didn't have any idea what is the percentage of error. And now with the analyzer, it's way easier to find the exact numbers. You can precisely see what is the volume, what is the flow, and what is the pressure. And then you know if the pump works right or not. You can hook up 4 pumps in the same time. The IDA5, it just does the job. I think people will be really surprised to find how easier their job can be once they use it. You have two different versions. The IDA5 is more for like working on your bench. It's not as easy to transport, but you have a lighter version for that. IDA1S, it's a very light and it's portable. You can transfer it like very easy to different places. We have a biomed in our department that goes to different clinics. He has to travel there. He's so excited because he can just take it, do his measurements, come back. It's simple as that. You have a touch screen. It's really easy to navigate. Being a biomed, you always have to go really fast. So equipment like that helps you in a big way. I always think Fluke Biomedical, they move with technology. And these days technology goes so fast. It's probably the most advanced infusion pump equipment that I used so far in my career.
Okay, this is a simulator. We use this to simulate the heart rate on an EKG. It only simulates the heart rate. It does not simulate the blood pressure nor the SpO2. The way you hook up your simulator, you put in your lead wires, just match them up, they're color coded, and plug them all in. Once you got them all plugged in, you got this confirmation download box that you can get rid of by pressing OK. You turn on your simulator like so, and you have your EKG line coming up. As you can see, we're right now at 200. We're going to bring it all the way down to 60, which is kind of your regular heart rate, around 60. Now you got some numbers on the top and some numbers on the bottom. The numbers on the top are going to pertain to when this button's pushed up. You're going to have your 60, 75, 100. And then if you want to go higher on the heart rate, you push the button in, and then you're going to be using the numbers on the bottom. 120, 150, and 200. Now these other buttons are used to portray the magnitude of the EKG line going across. You can make it smaller or bigger. You could go 0.1, a 0.2, or a 0.5. And this is going to make your EKG spike going bigger or smaller. And if you ever want to flat line the line in case, you know, the script calls for the actor to die, to the persona to die, all you got to do is turn off your simulator and you're going to get a flat line going across. Unfortunately, this would only simulate your heartbeat. It will not simulate your SpO2 or your blood pressure. Then we have attachments that we send, and you could actually use these and put them on a real person, and you're going to have your vitals coming up. That's your finger probe, like so. And then you attach your blood pressure, like this. And then you press start NIBP, which is going to start being. Unfortunately, these things are not calibrated, so you're not going to get real readings. Close enough, but not real readings. I'll stop it. I go ahead and stop it. Let's just stop it. It stops deflating.
Now we are in checking the accuracy of the new condom SPH sensor and extension cable. New condom 14 pin and 9 pin. Okay. We connect the cable with the machine. SPO2 connected with the extension cable. This is the SPO2 simulator to check the accuracy of it. We have set the SPO2 saturation in oxygen saturation in 98, and we needed to check the machine to see whether it is in 98. Yes, great. So this true cable is accurate.
Go over to the calibration mode. There we go. Now you'll see calibration.
Ultrasound calibration. You just press on that?
Yeah. So it's these 3 buttons
Start.
and then these 2 buttons here.
Okay.
Make sure your meter's on 0.
Bring it
Zeroed
back to
out.
0. Okay.
Get an accurate reading.
And start calibrating.
And it starts the calibration. You'll start seeing these numbers start to fluctuate down here as it's searching. No, pay attention to your meter. As you're ramping it up, you'll notice this starts going up. As soon as this
4
meter
watts, you said?
reaches 4 watts, and it comes up quickly too.
Okay.
Usually right up around 300 to something, 300. That's where you'll start seeing it start getting up close. And if you spin it too quick,
You might miss it.
you'll miss it. And it's kind of a pain to have to go back.
Mm-hmm.
Next. And I'll have you do it on 3.3 megahertz as well. And again, you're looking for 4 watts on 3.3 megahertz.
Next.
Good. And it kind of walks you through it.
Remove applicator from water. Okay. Next.
It's saving the calibration data.
Data.
Once it's clear.
Okay.
You should be good to go. If it doesn't
So
calibrate it again and you're still off,
Then you gotta replace something in this thing, right?
no.
No.
It's the board in this.
Okay.
And I'll show you what you need to do.
Okay. You guys replace the boards too, right?
Oh yeah, they're real simple. Right at 1. Right at 2. Right at 4. Just about right at 5.
Last one's 10.
Might go up to 9.4, but we're
What should be?
within-
That's
yeah,
good.
we're still within the 10%. You know. Make a liar out of me, machine.
So freaking sensitive.
Yeah, they are. Gotta go back up a little bit. Okay.
Oh, it's going wild.
Yeah, you'll get some wild numbers. It will settle down once the water stops moving.
Moving.
Yeah. Okay.
That's good, right?
Yeah,
9.4.
we're right good. Okay. So it did calibrate. It's usable.
Everything's okay.
Yeah. I've got a